Okay, so let's do problem 6 off the gold sheet. This particular problem is an adding vectors problem. A 110 Newton force acting at 90 degrees and a 55 Newton force acting at 0 degrees are applied to an object. What is the resulting force acting on this object? So let's go through the steps in order to solve this problem. First thing we want to do here is draw a coordinate plane, which I already did on the board. After we draw the coordinate plane, we need to place the two vectors that I already wrote on the board, 110 newtons at 90 degrees, 55 newtons at 0 degrees on the coordinate plane. Something you want to take note of is that the 55 newton force is obviously about half, it's exactly half, the size of the 110 newton force, and we do have to draw these to scale. So let's draw the first one, a 110 newton force at 90 degrees. So there's 110 newton force at 90 degrees. The second one we're going to write down is the 55 newtons at 0 degrees. So we need to draw this one about half the size. So 55 newtons at 0 degrees. Now, one of the most common errors that I see is students will connect head to head. They'll go like this to make their triangle. But this is absolutely wrong. You don't want to ever connect head to head to find the result. The way we add vectors is we have to pick one up and move it. And the one I usually use, the one I usually move is the smaller one. So I'm going to pick up the 55 newton vector, and I'm going to move it so that the tail is next to the head of the 110 newton one. So it's going to look like this. So I just moved the 55 newton force up there, make it a little bit better. And then I take my resultant by starting at the origin and drawing it to the head of the last vector drawn. So now I have a triangle that's drawn correctly. I have a vector with, that happens to be pointed in the correct direction. So let's finish our triangle. If this was 55, then this is 55. So what we're trying to find now is the resultant. So let's go on and solve for the resultant here. The resultant would be, of course, equal to 55 squared plus 110 squared square root. Or in other words, our resultant answer will be 123 newtons. Now the second part of that problem is we got to find the direction. And again, this is something a lot of students have trouble doing. So in this particular problem, I've got a triangle right here. And I'm going to find this theta right here. The theta that you always want to find is the one that's actually touching the origin. I could find this theta, but it's not touching the origin, and it's not going to help me out at all. So I'm going to always find the theta touching the origin. So I'm going to use the function tangent. Tangent theta is equal to opposite 55 divided by adjacent 110. And when I solve for that, I find out that theta is equal to 27 degrees. Now that's not my answer. That's my theta right here. So this is 27 degrees. My resultant direction is always from the east axis to my vector. So it's going to be that direction right there. So my answer is really 90 minus 27, or my answer is 63 degrees. So I'm going to go up here and finish my answer. The resultant for this problem is 123 newtons at 63 degrees. And I'm going to square that in, and I'm done.